Hey everybody, welcome to another week of Blubber Open Source Office Hours. Carl was mentioning he'd been thinking about some validation stuff, so why don't you kick it off, Carl?
All right, so as you guys probably already know, if you've been following the Derby community, there is a library called Razor Schema. Kudos to Pavel and what's his name?
Vladimir.
Yeah, Vladimir. And it does validation basically after operations have been submitted to share at the backend. I guess that most of the time you either want to validate the schema or rather you want to enforce a schema, in which scenario that doesn't really help since it's validating the updates afterwards. So even if it throws an error, it's already happened in the database. You can, of course, after that kind of revert the change, but anyway, it still doesn't really enforce the schema, and the likelihood of issues from the change is quite big if you rely on that. So I guess that doing validation of the data that you want to pass to the database is quite difficult, because either you have to make kind of a copy, apply the operation, and validate that before you actually apply it to the database or to share.
Yep.
And I figured that would be a mess to implement and probably very, very slow as well. So to be a little bit more pragmatic, it can be nice to validate stuff in the backend, I guess. For example, to make like minor enforcements or at least be aware of when the schema is broken. But to be a little bit more pragmatic, what typical pattern we use is to we typically have like just a component model object or path that is just temporary at the client, where you add all your data, or it's copied. It's a copy from the database, and then we edit that, and then we validate it, and then we save it back to the database, so that we don't really modify the data straight away, like most CRUD apps do, basically. So when you don't need like the real-time stuff. For all of those scenarios, it seems like, once again, it would be very difficult to validate the data before you've actually done the change. It might also not be optimal from a user's perspective, because you probably want to like enter your email in the wrong format before the validation kicks in.
Right.
Also, because in some scenarios, like let's say you have a field and you want to enforce a number of above 100, I mean, then you can't basically enter any number, because as soon as you write 1, it will fail and it will revert to nothing. So basically you want to do validation after the fact, and I guess that's the only point in time where you want to do validation.
There's a few things going on. So one of them is, sorry, there's kind of Carl, can you maybe mute? Cool. So there's a few things going on. So one of them is like UI interactions. You usually want to write validators for those differently anyway, because, for example, like your Razor schema, style schema, probably enforces a lot of rules all in one blob. And then if, like, for example, your email address is wrong, you want a specific UI to like help you through fixing that problem. So with a lot of UI validation stuff, I think the right answer to that is actually just use HTML5 style, like, types for fields that enforce rules using browser conventions, or write custom JavaScript that does that for like the very first thing. So if you're making a form, like, you should client-side test the specific form fields and push people to fix those specific problems. That still won't catch a lot of things. So then you kind of bring up like, well, there's a few tricky things around, like, when is the right time to do strict validation. It could be good to do strict validation on the client before sending the ops to the server. And as you mentioned, there's an issue with copying. But that would be still probably a good thing to do. I don't know that it necessarily buys you anything unless you expect to fail frequently. So basically, like when something's in the client, it's really easy to fail it and remove that op because it's never been sent to the server. So we can just like remove the op, but the data actually has been changed. So that's the issue. And not all ops necessarily can be reversed. So then what you have to do is you have to like figure out a way to rebuild the history, which requires keeping around a copy of the document that's like in its pristine form that is reflective of the database and then the operations. It's just something that SharedJS doesn't do right now. It doesn't actually keep around enough state to make that efficient in the client, sadly. So like you kind of have to do it before you even mutate the data in the client, which is there's not a way to do at the moment other than like adding a bunch more code. But there's not like a straightforward place to hook in. On the server, it's actually kind of a similar story, but it's easier to throw away stuff that's in flight, which is what the validator stuff does before it writes it out. But then the client's still stuck in this same state problem. So really, the server thing isn't too tricky. The hard part is the client state. Like, how do you reverse back to what the document was previously is the real issue. So I think like that's just something that needs to change in the framework if we're going to support it really properly. And there's also, this is also relevant because your database writes could fail. So this is something that I'm actually working on, or will be shortly, not literally right now, but in the next couple weeks. There's a lot of reasons why a database write might fail, and right now SharedJS does not deal with it well. It basically accepts anything that's like a valid operation without waiting to write the persistent store. But like you might have like a Mongo unique index, or you might have a shard key that requires documents always have that shard key, or there's various rules that Mongo enforces and other databases could enforce too, which are effectively the same thing as validators, but they don't happen until after you've tried to write the data to Mongo. And right now there's not a way for that to get played back. So the first problem is making sure that on the server that can get dealt with properly, which I'm doing. But then you still have a client that's in a broken state. So to be honest, what we do right now is if this ever happens, we just like throw up an error and tell the client to reload. Like we don't even remotely try and fix it. There's not like a proper way to do it yet.
All right.
So what we could do is keep around a copy of the data that's the last known sort of committed data, as well as the data that's being mutated, but it's pretty expensive to be deep copying all the time. Another alternative, if you think failures are rare, would be to just, when failures happen, go ask the server for the document again, which is going to take a lot longer in a failure case. But if failures are rare, it's a lot better because success is expected most of the time. So that might actually be kind of a good compromise solution, is to write into the share client something that will, if there is a validation error, like ask for the data again and then like refresh all the data in the client. It does have the kind of unfortunate effect of like not translating super well into things for Derby or like your client-side code to update potentially. So this gets into another class of problems, which is, well, if you're writing your app assuming that all the changes will be these little changes like, oh, change the string or like insert items into a list, and then we realize, oh no, that data is totally whack, let's just reload all the data. You might not have all of the listeners set up to actually make your state in your app consistent with that event of like reloading all the data. So we don't want to emit a change event because we haven't necessarily changed the data. We have to emit like a load event or something like that, and whether or not you handle that load event correctly, your app might get screwed up because it's kind of an edge case and you probably didn't test it. So Derby could handle it, but people's app code might be listening to model events and might be wrong because they don't handle all of the events that could happen. So that's a whole problem. It goes pretty deep. Like this validation stuff seems simple at first, but like I can do the server side of it pretty well. And there's that one issue I mentioned of like writing to Mongo not currently being quite right. But the client side is actually quite tricky. In short.
Yeah. I guess one kind of simple fix would be to do like kind of like you proposed, like just validate the like the temporarily stored client only like model object path, whatever you would call it, and just validate it before you save it to the database and do your custom validation, or if you have a helper plugin for that or a library, whatever. That can probably be generalized quite neatly. But for really enforcing the schema, I guess, yeah, if it's a rare case, it might just be easier to use like raise a schema, and then when an error is thrown, just reload the whole page. I mean, why not?
Yeah, I mean that's kind of what we do.
Yes.
Unfortunate, but it works.
It's a good solution for most apps.
Yeah. So, yeah, the client-side stuff, I mean, what would be nice is, like, if you could sort of, if you could, like, have an API where you could say, hey, I want to do this thing, tell me about it before you actually make the change, whether it's going to cause a problem or not. That could be made a little more, like, I'm assuming that you would kind of be actively calling this thing, not like it would be running all the time for every single edit everywhere. You would like pass it an operation that Racer's about to create. It would look at that operation and try and figure out whether it invalidates the schema or not. That would be like one thing, but that would really break the type abstraction a lot, like the way the OT stuff works. Trying to think of other ideas. You could just try and like, there could be a more efficient way for the operations to like return a copy document instead of mutating the document if they were to only copy some of the fields, but it's still a lot more overhead than the way it currently works. I don't know. It's like, it seems like it's really simple, but the fact is that OT being, the way that OT works is it mutates things as it goes. So you don't know what the end result is until you've mutated the data. And since you've mutated the data, now you don't have the old data. It's not like immutable functional programming where you can look at the old data because you just made a copy. So I don't know. There's not like an elegant, fast solution, I guess.
Maybe it can be solved from like a UX perspective. Maybe you just kind of you allow to write anything into the database, but you just invalidate the schema and show the errors to the user that is currently editing stuff. So he's able to write the improper data, but you just show him that the data is improper and he cannot like progress further. Like so, like it's kind of a solution from the UX perspective, not from the generic perspective.
You could do that, but it's kind of a question of like, what do you want to be your actual schema? Like, do you actually want to force the database to always have data in a certain format, or do you not want to do that? Like, it really is a binary thing where it's like we either do enforce or don't enforce the schema at some level.
Right.
And if you do enforce it, you just can't write the data in that format ever, or like write out the ops in that format ever. And then, if the schema changes, you have to figure out how you're going to migrate the data to fit the schema. Like, it is actually kind of hard to apply a schema to OT, or at least like a particularly rigid schema. Like, you could have a schema that's like, this data will be JSON, right? Like, that's still a schema, but it's a very loose schema, versus like, this data will have a date here and this count, which is more than this but less than this. Like, those kind of things are a lot harder to enforce with OT, because if you then later migrate your schema, you now have some ops that are only valid at a previous schema, and then some ops that are only valid with a new schema. And how do you keep that around is an interesting question. And we just frankly haven't tackled that. So I don't really know what the right answer is to that one.
Yeah. Well, it's more like if you want to go deeper into protecting your application from some invalid like database state, then you have to go all the way down to the server-side validation, like protecting it all the way. But for most cases, I think the client-side validation is fine. Just the client-side validation, maybe without even forcing some particular schema, just showing an error when something wrong is inputted.
Yeah. I mean, so I'll be honest, this is actually a problem we have pretty regularly, is like, we have a lot of data that's in weird formats. And so like the first thing you noticed I did was I made it so you can't just like arbitrarily set things and create documents, because that was a thing that actually kept happening to us, is like we would randomly end up with documents that we did not intend to create. And some part of it is like the API can just sort of reduce the ability for you to do things to shoot yourself in the foot. But to a large degree, the API is designed to be very schemaless. I mean, I guess with the schema, one way to think about it is it's not really a schema as much as like a schema for new things, if that makes any sense. It's like, we won't create new data that doesn't look like this, but old data, it's okay to be out, not in this format. At least it's more of like a linter, if you will, rather than like a strict schema. So that will prevent more corrupt data, or that'll prevent corrupt data from going into the database, but the data in the database could easily still be out of sync with that.
Well, there is no other way around it, right? You still have to write a manual migration to adapt your existing data to a new schema.
Yeah, totally. It's just there actually is sort of a weird difference between this and like, you know, if you're using like Postgres the normal way, right? Like, what ends up happening is when you want to do a database migration and like change the way that your data is structured, you just do it and it's done, and the data before doesn't exist anymore. Because it's like everything has been migrated, it's now in this new format. The old data just doesn't exist. Whereas with OT, like, we actually kind of have the data in the old format too. And so, for example, here's like a real thing that could happen. You might have an application out there in the wild that's allowed to do certain stuff because you didn't restrict it. So it's allowed to insert items into a list, and there's like a button that inserts an item and some code that runs that like formats that item. And then you change like the format of the data in the item. Like you change the name of a property, let's say. So then you could run a migration for all the old data and change the property name. That's easy. You just create ops that change the property name, not a big deal. Then for new data going in, new clients, you could update the code to make that there. But do you want to force all the old clients to stop working right away or not? And if somebody were offline and they come back online, what do you do? So if they come back online, we could either tell them that all the changes they made while they were offline are totally invalid and like they can't commit them, or we could let them commit them, but they're going to commit them in the old data format. So if they commit them in the old data format, we could run the migration again on those documents as long as the migration is idempotent, should be. But now, how do we run that migration continuously? So what you really want to do is like have kind of like a migration for the old data format continuously, at least for a while, until you get rid of all the old code that makes data in the old format. Like that kind of problem just is very unique to the way that the data model works in Racer/Share.js. And you just don't run into that kind of problem with a traditional web app because you send your like intention to write things to the database in like a RESTful way, and then you update all your server code all at once. And so when you do update all your server code at once, it suddenly starts writing in the new data format. You do a database migration, all the old data goes away, and you never think about it again. So that's like the nuance for why the validation stuff is actually really complicated is like, it is very likely that the data is going to be in different formats. So the other way to deal with that is actually to just do, to just allow for data to be in multiple formats. So like in our app, for example, we have a lot of data that's in a format that's old. Like we have an old notes format that's different than our current notes format. And we just kept the old code in place to render the old notes format, as well as the new code, and change the name of the format. For a task queue, when we change tasks substantially, sometimes we just like use a new name for the new task and like leave the old task around for a while and don't delete it till later. So we're just allowing two versions to exist at the same time. But sometimes we do migrations. Like sometimes we choose one or the other depending on the situation.
Very pragmatic. I like that style.
Yeah, so that, I mean, that's one solution. So yeah, I mean, basically the difference is like you're migrating in your app versus you're migrating in your data. Kind of the way to think about it. I don't know. So that's why I say it's more like a linter, where it's like you're not really ever going to have a schema because for a variety of complicated reasons, it's actually very, very hard. And you just kind of think of it like, oh, I don't want more dirty data going in. Not like I'm actually going to make sure the world is entirely consistent. I think that's a more pragmatic way to deal with stuff like this. I imagine that like there could be such a thing as like a real-time migration, where you describe data in the old schema format, the migration from the old schema format to the new schema format, and if data comes in the old schema format, it's allowed and it gets migrated before it gets written down. That sounds great. But we don't have anything like that. But maybe that's the future. It's like you actually do define schemas and the transforms between them. It sounds hard though.
Yeah, it does.
Yeah, because there may be clients that are two versions of schema away from your current version.
Yep. You would need to define all of the steps, make sure they're all chainable. If any of the schemas rely on each other in weird ways, like what if you have, like, are the schemas global, like for all your data store at once? That might be the simplest way to do it. But you know, what if you're getting data and joining it in order to do your migration because you decided, oh, we're going to combine these two documents, right? Pretty practical thing that might happen. So you're like, oh, I need to query this other thing to do the migration. Well, now that's getting pretty complicated, especially if the thing you're querying has already been migrated to the new version. So do you back migrate it into the old version in order to do the forward migration of the other data? How the heck does that work? What if you need to merge data in a lossy way, which sometimes migrations are? So I wouldn't say it's impossible, but it definitely is not happening, or I'm not working on it, anyways. Sounds too hard.
Oh, by the way, with the merging of the documents, you reminded me that earlier you recommended to everyone to, if you have some document-like data, make it a separate collection instead of trying to fit it inside of some existing document, like existing collection, like document of some other collection. Do you still recommend going this way, or are there some benefits in some cases to keep some list of documents inside the document of another collection?
Well, a lot of that just comes down to Mongo specific stuff in particular. So this is actually like a really unsolved problem, to be honest, for us. We do a mix of things, and we're trying to get better at it, but it's still a little messy. So one thing is like there's times where there's data that you need a lot and data that you don't need very often, and getting the data that you need, like putting all that in one document has the downside of incrementing like the version on a big document a lot and like dealing with a big document a lot internally, which isn't always as efficient. So, and also projections at the moment are not awesome, kind of crappy actually. So I intend to rewrite projections to make them a lot more usable. Basically, instead of creating, like creating another collection name is basically just a hack to avoid having to think about how the heck do we combine operations from multiple different projections together into a single document that's like a merged projection, which is not impossible, it just was hard, so we just kind of punted on it. I intend to actually do that because as I've been thinking about how do you do lots of projections, which is actually really important if you want to have a highly performant app, is like every single time you need data, you should get exactly the data you need. So I'd like to be able to do projections like per every query in a lot of places where we don't right now. And the main reason we don't is it's just too inconvenient, frankly. And so that's a thing I'm thinking about, and we'll probably work on. Where was I going with this? I totally lost my train of thought. But anyway, so projections. How did I get into projections? What question did you ask me?
About whether it's more optimal to have a separate collection or embed things.
So part of the trade-off in embedding things has to do with projections, because like if you can easily project stuff out of the document, then you don't pay as much for it. But still, even then, there's like internally the back end has to like load the whole document, be able to modify it in a lot of cases. So if there's a bunch of data that you're just keeping around for archival reasons that's associated with another document, something that we just started doing is actually creating a document in another collection with exactly the same ID. So if you want to get it at the same time, it doesn't cost you anything. You don't have to do a lookup to do a lookup. You just query two different collections with the same ID. So in our case, we have like we have profiles of people who are applying to your job, and then we also have a bunch of data. A lot of times that we like never really show, but we store it for various reasons. Like it came from an import, for example. So we currently store too much of that data on one document and never use it. And we're going to probably move it to another collection that's just like profiles extra or whatever. And that's just going to have the same ID, so that if you know you need this profile, you also can get that data if you need it without doing a database call, because it's just the same ID. So that's one strategy. The same thing's good for like user. Like you might have user documents, and then you might have like user-specific settings. So if I know my user, I can go get my user-specific settings, And in that case, it's actually a totally different reason you might want to do this. In that case, you might want to do this because on the user document, you don't really change it much. It's like your name and your email and some other stuff that other users need about you. But on your own user settings, you change it a lot because, whatever reason. So there's a lot of operations on your user settings document, and we can project those out before sending them to other people, but we still have to tell them about the version increments in order for a lot of the OT stuff to work right. So we're actually sending a bunch of messages that are effectively just empty. They're just like, hey, the version changed. We don't tell you what happened for like all of the users to all of the other users versus like if only the document for your user, which doesn't really change much, is shared. That's not happening because only that user has its own settings document that's changing a lot, and they're getting all updates on it. So it can be a good way to actually shard PubSub effectively. I'm also working on a change to make sharding PubSub like a real thing, which will happen soon. I'll talk more about it when it's done. But basically, you'll be able to add custom channels which will allow people to not get updates on stuff, which will be great. And that's one kind of thing. Another thing is it just is more efficient to get one document than to get a bunch of documents with Mongo, and the round trip time. So sometimes you want to embed stuff because you like always use it together. But then now you have two copies of it, so now you have to update one when the other one changes. You're basically just trading off like read complexity versus write complexity and the difficulty of keeping things in sync because Mongo doesn't have any way of doing automatically computed data based on other data. Some databases do. It's one thing I'm very sad Mongo doesn't have. But like, SQL databases have various concepts called like views, which are kind of like this. Materialized views specifically is what I mean. So that would be sweet if Mongo had that. So yeah, it's complicated in short. We do both. It's mostly a write versus read complexity thing. So most of the time in our app, most things are reads. Like the large majority of what makes things slow is getting data, not writing data. So we're starting to move toward storing data more aggressively because that tends to be what's like less slow than the getting of the data. So we're optimizing more for this is a classic problem. It's just fan out versus fan in. We're optimizing more for fanning out, in other words, writing data to multiple places, versus fan in, which is reading data from multiple places, because most of the time that's faster for us. But it totally depends on your workload and the data structures, and there's just not a simple answer.
Okay, thanks. Well, this was also one of our things that we refactored recently. Well, like not recently, like 6 months ago. Mm-hmm. We had our games store the data for all the players inside of the game, but then when we decided to push for a Coursera contract, like we have like 5,000 players inside one game, then obviously it became impossible to fit all of those players in one document. That's when we had to restructure everything to have a separate document.
Yeah, there's some practical limits, like Mongo has a 16 megabyte document size limit, which is huge, right? Like 16 megabytes is really big. But more importantly, like if you're loading 16 megabytes of data,
yeah, that's the problem.
That's like the real problem.
Yeah.
So yeah, it's basically like if you're gonna have thousands of things, embedding it in a document is often not gonna work out.
Yeah, so like a rule of thumb over here is to basically, if you have something that you know is not gonna grow very much, like more than like 50 instances, then you can safely embed it. Right?
Yeah, that's basically it. I mean, embedding is definitely more efficient if you most of the time need all the data that you're embedding. it's definitely a lot faster. It also is just simpler on the back end because it doesn't have to like deal with a bunch of different objects. It's just like one giant object is actually like less bookkeeping and everything for the back end to deal with, especially if those things get modified together. And then the other concern is like atomicity. Like you can only OT within a document, so it's just not possible as of currently for like if you and I modify stuff that needs to be modified kind of within a document as well as between documents to make it consistent. You can't actually do that, so there's a possibility that it could be inconsistent. Versus within a document, it will definitely be consistent using OT. So whether or not that's like a concern is very application specific as well. The other thing we're actually running into is like Mongo is actually just a terrible document store for some kinds of things. So we're just having to use like Elasticsearch for more and more stuff. So that's just that. So like specifically we have tags, and we were storing tags in Mongo for an account. And what we actually need to do is store the tags instead of like having a centralized like what are all the tags for this account. Instead of doing that, because it's gotten unwieldy, we're just, which we were using for like an autocomplete, right? So we're moving it so that we're just storing the actual tag values on the individual documents, which there could be millions of, in theory. And in theory, many, many thousands of unique tags, and then using Elasticsearch to like power the autocomplete and getting just what we need. So that's kind of like where you end up eventually is you just use a search engine because that's what you have to do.
Oh, one thing you also mentioned is that you have a profile, like you're going to just move the profiles into two different collections, right? And the profiles and the profile extras with the same document IDs.
Right.
So are you actually, like, another thing is, are you using, well, you're doing it like the same IDs because it's faster, you don't need to query stuff, right? You can just like query the same ID that you know, and that's it. But are you also using the objects as IDs? Like, I think Mongo allows it to use an object as IDs. If you, for example, have some collection, some collection that has documents which depend on two documents of another collection. Like,
I actually don't know about that. What the rules are there?
So, like why I mentioned it is because we, for example, we decided also to get rid of one of the queries by having instead of like for the we have games and players, and we also need to involve users. Kind of when we subscribe for our player, like we know the user already, we know the game that he's going to play, and we did it so that the ID is basically the GUID of the game underscore GUID of the user.
Right.
Is it a good decision, or can you like use an object instead of an ID, or
well, I don't know whether Mongo does or doesn't support that, but the issue you'll probably run into is that the queries have to be tracked internal to Racer and other things in a number of places, and so the basic rule is that the query needs to be like JSONifiable. So basically, like internally, Racer creates hashes of queries based on just JSONing the object, or JSON stringifying. Like an object reference, for example, probably wouldn't actually. Well, it would just like flatten the object. So it would sort of end up being the same thing as like manually constructing the ID from its properties. anyway, because we turn it into JSON. And that's also how we'd send the message to the server, like, hey, here's this document we want to create. Here's the ID. Like, the ID has to be a string that doesn't have a dot in it in order for Razor to work right. So whether or not Mongo can actually make like it sounds like you're talking about making like almost like a hash map where it's like actually the key is an object. Like, I don't know if Mongo supports that, but at some level, because we have to turn things into strings, you practically probably couldn't get away with that, and you'd have to like do more or less what you're doing, where you're just like combining a bunch of IDs to make a unique ID.
So, do you think it's a good approach? Like, are you using it somewhere in your application, or?
I mean, it's not a bad approach as long as they're still unique. So a good thing about it could be that it allows you to kind of uniquely address something based on some other stuff you might know already, instead of having to do like a query. And if that's a common lookup, like, sure, sounds great. It seems good. I would say that it basically only lets you do like explicitly one kind of query, but that's still a win, essentially. It may or may not be better to get a bunch of documents by their IDs versus a query, a more traditional query at the moment. So I've been working on reducing the amount of complexity in shared.js LivePD and eventually getting to a place where these things are actually really very efficient. But at the moment, to be honest, I'm not sure which is more efficient, to like query for a whole bunch of different documents by their IDs or to do it by a single query. Kind of depends on the number of documents. I suspect that it's more efficient for a small number of documents to do it by ID, and for a very large number of documents to do it by query as things are written right now. That's my guess.
Yeah.
So, but honestly, the only way to really know is to try it. It's a complicated system. I can't predict everything.
Okay, thanks.
But yeah, that's a creative solution. All right, I should probably run. How you guys doing? Any other questions or anything come up?
No.
No, not really.
Cool. All right. Well, see you next week, everybody.
Yeah. See you. Thanks, Mike. Bye.
Yeah.